There we go, we got it. Okay. So we're starting off today with how to prove two functions are inverses. How to prove two functions are inverses. So I'm going to say, let's write this, two functions f and g are inverses if and only if f of g of x equals x and g of f of x equals x. Okay, so let's do a problem. If f of x is equal to 2x plus 4 and g of x is equal to a half x minus 2, are f of x and g of x inverses? There is only one way that I will accept algebraically for you to show that they're inverses. It will be that we have to show f of g of x is x and g of f of x is x. So let's do our two tests. I need to show f of g of x. Well, we know g of x is a half x minus 2, so this is going to be f of a half x minus 2. So now I'm going to go to f of x. Wherever I see x, what am I going to substitute in? A half x minus 2. So this is going to be 2 times a half x minus 2 plus 4. At this point, we have to distribute in that 2. So we're 2 times a half x minus 2 times 2 plus 4. When we multiply the half times 2, those 2's cancel. So now we're left with x minus 4 plus 4. Well, what's a negative 4 plus a positive 4? 0. So did we just show that f of g of x is equal to x? Yes, we just showed one part of our proof. This is not enough. So we showed f of g of x is x. What have we not shown?
G of x.
You got it. We have not shown g of f of x. So now that's our second part here. So now this is going to be g of 2x plus 4. So wherever I see x in g of x, I'm going to now substitute in a 2x plus 4. So this is going to be a half times 2x plus 4 minus 2. I have to distribute that half. What's half of 2x? X. What's half of 4? 2. So I have x plus 2, but then I still have that minus 2. Again, positive 2, negative 2 cancels out. So what have we shown? G of f of x equals x. Are these two inverses? Yeah, the 3 little dots in like a triangle mean therefore inverses. We proved it. You guys try this next one on your own. Ready? If f of x is equal to 3x minus 5, and g of x is equal to x plus 5 over 3, are f of x and g of x inverses. Also try this one. So you're doing number 2 and 3 on your own, and then we'll go over it. we ready? 2 more minutes? Sure. Okay, for the first one, how many people said yes, they are inverses? All right, second one. All right, how many people said yes, they are inverses? How many people said no, they are not inverses? Okay, we're going to go with yes, that they are, and we'll do it in a minute. All right, for number 3, how many people said yes, they are inverses? How many people said no, they are not? All right, I'm going with no also. We'll do it. All right, let's go through these since we didn't all get the same answer. Yeah. Okay, so for the first one, we need to show 2 scenarios. We need to show f of g of x. I'll do that one first. So we're going to do f of x plus 5 over 3. So I'm going to go to f of x. Anytime I see an x, I'm now substituting x plus 5 over 3. So we have 3 times x plus 5 over 3 minus 5. These 3's cancel. So we're just left with x plus 5 minus 5. Positive 5, negative 5, they cancel. So we get f of g of x is equal to x. We're not done yet because I have to show both scenarios. So now I also need to show that g of f of x is equal to x. So we're going to have g of 3x minus 5. I need to show this. So now this is going to be 3x minus 5 plus 5 over 3. Well, in our numerator, a negative 5 and a positive 5 cancel, so now we're left with 3x over 3. How come I am allowed to cancel these 3's out? When before I told you couldn't cancel out the 1's, but now I'm canceling out the 3's. Nico?
No, like signs, like dividing the terms.
Good. This is still a monomial. It's the binomials or trinomials, the bigger ones. Once you add addition or subtraction signs that you can't then just cross out a number or cross out one variable. So this shows that g of f of x is equal to x. So are they inverses? Absolutely. So that was number 2. Now let's look at number 3. So I'm going to first find f of g of x. And that's going to be f of x plus 1 over 2. So we're going to have 2 times x plus 1 over 2 plus 1. The 2's cancel. So then I'm left with x plus 1 plus 1. Well, what's 1 plus 1? 2. So this is saying f of g of x equals x plus 2. Can I stop here? Absolutely, we can stop right here because it was an x. Not inverses. F of g of x does not equal x. Okay, next part. So now we're going to talk about how to find inverses algebraically. All right, to find inverses algebraically, you are going to switch x and y, then solve for y. And also we're going to put a note. The domain of the original is the range of the inverse, and the range of the original is the domain good of the inverse. Are we ready? Okay, so the first thing I want us to do, number one, I'm going to ask us to find the equation of the inverse and the domain and range. We ready? Okay. F of x equals 4x plus 1. You need to be able to visualize what these graphs look like. You need to be able to visualize what these graphs look like. What is this, 4x plus 1? Only one person, two people? Only two people know what this is. You've been doing it since Algebra 1. Charles, what is it? It's a line. This is a line, right? Y equals mx plus b. That's a line. So if this is a line, what's our domain on a line? All real. You got it. Our domain is all real. What's our range? All real. You got it. Okay, so here we have f of x equals 4x plus y. My directions to find the inverse, I told you to switch x and y, then solve for y. There's no y here. I wrote f of x equals 4x plus 1. Where's the y? You don't know? Gianna? Good. Remember, guys, isn't f of x interchangeable with y? So this is really y equals 4x plus 1. So now I'm telling you switch x and y. So I'm going to say, give me another color, x equals 4y plus 1. I switched x and y. Switch x and y. Then solve for y. Yes.
Why wouldn't you just solve for the original x? Isn't that the same thing?
It is the same thing. It is the same thing, but sometimes it could get a little bit confusing. So when you, because normally we have like y equals something and that's our function. So when you see x equals, it might throw you off. It's up to you. You don't have to if you don't want to. So now what we're going to do is we're going to now solve for y. When I solve for y, I'm going to subtract that x over, that 1 over. So x minus 1 equals 4y. Then what am I going to do? Divide by 4. So our new equation is y equals x minus 1 over 4. But we're not going to leave it y. This is the inverse. Does anybody remember? I briefly showed you last class. How do we write the inverse of a function? Erin?
-1 exponent.
You got it. That -1 exponent. So f raised to the -1 of x is equal to x minus 1 over 4. All right, but that wasn't it. What else did I ask you to find? The domain and range of our inverse. Well, remember, the domain of the inverse is the range of the original. Well, the range of the original was all real numbers, so the domain of the inverse is all real numbers. The range of the inverse is the domain of the original. So the domain of the original is all real numbers, so the range of the inverse is all real numbers. So this is our final answer. All right, next one. G of x equals 2x over x plus 3. Actually, I'm just going to have two over x plus 3. Let's do this. I'm going to make it 1. Sorry. 1 over x plus 3. So let's figure out here what our domain and range is of our original. What is this? The one with the asymptotes. This is a rectangular hyperbola. And where has my asymptote shifted? How many units where? 3 to the left. 1, 2, 3. Any up or down? No. So our graph looks something like this. Do we agree? So what is our domain here? Domain is the x. So basically it's every number except what on the x? Nope, that's 0 right here, right? -3, you got it. X cannot equal -3. Okay, what about the range? It's every number except for what? Gianna? 0, you got it. So y can't equal 0. All right, we ready to figure out the inverse? So what did I say to do? Switch x and y. Switch x and y. So I'm going to have y, this is the original, y equals 1 over x plus 3. So we're going to have x equals 1 over y plus 3. I cannot solve for something that's in the denominator. I cannot solve for something that's in the denominator. So I need to get it out of the denominator. The way you get it out of the denominator is you multiply both sides by that denominator. So these cancel. So now I have x times y plus 3 equals 1. I need to solve for y. So I'm going to get y all by itself. So I'm going to divide by x. So then I have y plus 3 equals 1 over x. What should I do next? I got to get y all by itself. So what should I do? Subtract the 3. You got it. Isn't isn't this another rectangular hyperbola? Yeah. But I don't leave it y equals. What do I write it as? F to the negative first of x equals 1 over x minus 3. This is our inverse. I also need to know the domain of this inverse. So remember, the domain of the inverse is what of the original? The range. So go back. The range was y can't equal 0, so the domain is not y can't equal 0, it's x can't equal 0. And the range is the domain of the original, which is x can't equal negative 3, but now it's y can't equal negative 3. Any questions before I step it up and make it a little harder? Yes?
Basically, the goal is just to isolate the y. We don't really have to do anything to the other side once we have the y by itself.
Yep. Okay, so now I'm going to do some homework. I'm going to do some of your homework problems. So I'm hoping to do at least 1 or 2 of them. So the directions are going to be find the inverse of f, state the domain and range of f and the inverse of f. Okay, so this is number 6 from your homework. Number 6 from your homework. F of x equals the root of x minus 8. Now I'm giving you a restricted domain for x is greater than or equal to 9. Do we agree this is a shooting star? Yeah, so so we know it's only going to be going to the right, right, forever. But we have to figure out where the range is when x is greater than or equal to 9. So what we're going to do is we're going to take the f of x. So I'm finding the range when x equals 9. So we're going to take basically f of 9. So we're going to do the root of 9 minus 8. What's the square root of 9 minus 8? 1. The square root of 1 is 1. So on my graph, where am I starting? I'm starting where y is 1. So our domain is x is greater than or equal to 9, but my range is going to be from, I'm going to do brackets, from 1 all the way up to what? Infinity, because it's a shooting star, right? It just keeps going up forever. Okay, so we found the domain and range of the original. The domain was given to us because they gave us a restricted domain. And that's going to be more along the lines of what you're going to be seeing on tests where I give you a restricted domain. And then you use that restricted domain to plug in to find the corresponding range. Okay, so now we're going to find the inverse. So I'm going to say y equals the root of x minus 8. We're going to switch x and y. So x equals the root of y minus 8. I now need to solve for y. How do I get rid of a square root? How do I get rid of a square root? Luke? square both sides. You got it. So now this is going to be x squared equals y minus 8. Then what are we going to do? Plus 8. So x squared plus 8 equals y. Or we can say the inverse function equals x squared plus 8. I still need my domain and range. So remember, the domain of the original ends up becoming what? The range of the inverse. So now my range is going to be y is greater than or equal to 9. My domain is the range of the original, which is going to be 1 to infinity. What is this?
Parabola.
A parabola. What was my original?
Shooting star.
How is the inverse of a shooting star a parabola? Isn't it just supposed to be a reflection? So why is the inverse of a shooting star a parabola? It's not a parabola because I have the restricted domain and range. So what ends up just showing up is a shooting star. Do you want me to sketch it for you real quick? Or not really? I could go into Desmos. Okay, we'll stop here and then I'll go into Desmos to show you. Could somebody remember the